Alright, in today's lesson we're going to quickly look at this thing called a piecewise function. And a piecewise function is one, again, if you haven't figured it out by now, mathematicians, we are highly creative, sarcasm, in labeling things. So this piecewise function, it's defined in pieces. Like we might have something like, I'm just making one up, x squared if the x's are less than or equal to 0, and 1 over x if the x's are positive. Okay, so what this does is, it depends on what your input is, like f of negative 3, well, which piece do you go into? Well, whichever one you make true. So here our input's negative 3, so x is negative 3, it's less than 0, that's a true statement. So it's going to go into that top piece and become negative 3 squared and gives you 9. If we were to plug in positive 3, then it would go into the bottom piece because that's where the positive inputs go, and you get 1/3. Now these are all over the place. I say all over the place. You run into these in like your post office, where they charge you more when your package weighs more. When you go to the movie theater, you run into this because you get to pay child prices if you're under, like if you're less than 12 years old, probably strictly less than 12. And then you pay adult prices on your 12th birthday, greater than or equal to 12. Until you turn like 60, and then you go back to kids' prices with the senior citizens. But that's what you pay depends on what the input, which category or which statement you satisfy by your age. So how we want to sketch a graph of these. So let's look at, we can go back to that one. That one's a nice one to start with. X squared if x is less than or equal to 0, and 1 over x if x is greater than 0. Okay, so I picked on two toolbox functions to make our life easy to start with. So good old x squared, its entire graph looks like this. That's the entire graph of x squared. Well, for the graph of this piecewise function, I can't use the entire graph because I'm restricted to just using x squared if x is less than or equal to 0. So what I have to do is come over here to my x squared graph and just use the part that satisfies the condition of x being less than or equal to 0. Just this left-hand side where x is less than or equal to 0, I'm going to use and graph here. So there's the first part of my piecewise function. It's x squared, so it's half a horseshoe if my x's are less than or equal to 0. My other piece of the piecewise function is 1 over x, which its whole graph is these two little skateboard ramps. But it's only good for x's that are greater than 0. So it's only good for the x's over on the right hand side greater than 0. So we'll just copy and paste the part that we need over here. And so here is the entire graph of this lovely function, x squared if x is less than or equal to 0, and 1 over x if x is greater than or equal to 0. Let's look at another one. Let's say that we have x squared plus 3 if negative 3 is less than or equal to x, which is less than 0, and 3 minus x if x is greater than or equal to, if 0 is less than or equal to x, and x is less than or equal to 4. Okay, so I made the conditions uglier, but all it's going to do is it's going to give us endpoints on both sides. So, looking at this first piece, x squared plus 3, the graph of that piece, it's a good old x squared graph that's been shifted up 3 units. So there's the entire graph of x squared plus 3. Okay, well, I can't use the entire graph. I can only use it from negative 3 up to 0. I can't even use it at 0. So if I come over here to negative 3, I'm going to get 12. Negative 3, 12 is on this graph. And I'm just going to use the piece from right here, from x equal negative 3 to x equals 0. So it's going to be 1, 2, 3. It's going to have circle there and come over here to negative 3, 12. So we have this finite little arc. So that represents this first piece. And then 3 minus x, that's just, or if you prefer, negative x plus 3. Now it's in mx plus b fashion, so it has a y-intercept of positive 3, and it's going to have slope of negative 1, and it's going to have an x-intercept of 3. So there's the entire line of 3 minus x. But again, I can only use a certain piece of it because of my condition is I'm only using this rule, 3 minus x, when my inputs are greater than or equal to 0 but less than or equal to 4. So from 0 to 4, which 4 gives you negative 1 as your output, I'm going to copy and paste that little chunk right there and get my graph here to 4, negative 1. So here's my entire graph as I circled my pad without touching anything. Here's my entire graph of this piecewise function. If g of x is equal to x squared plus 3 for this input, negative 3 to x, then you're on this little arch. And if g of x is equal to 3 minus x for x greater than or equal to 0 but less than or equal to 4, then you change to this straight line and come down there to 4. This function's domain, if we wanted to talk about domain, would be from negative 3 to 4, because that's what our condition said for the x's. And the range, the set of outputs, we got a high of 12 and a low of negative 1. So our outputs are somewhere between negative 1 and 12. And that's really all there is to a piecewise function, is depending on what you look at your inputs and you plug it into whichever piece it satisfies. If we're sketching a graph, then we will just sketch each piece for that little interval that we needed it on. That's it. I told you it was a quick section. I'll talk to you later.